So, welcome everyone. It's another lecture, and this time we will be talking about machine learning, or in other words, data-driven models. What is machine learning? Machine learning is nothing more than you try to build a model based on data. So, basically you train or build models from data. Let's have an example. For example, you already heard about first principle modeling, when you have some sort of physical or thermodynamical laws you use to build a model. It's so-called first principle models. In this case, we consider completely another approach. For that, let's consider an example. So we have a simple chemical reaction. And in this reaction, we collected some data. So basically, it's a concentration of our product over the time. And normally, it depends on the reaction, on the order of the reaction. It might look differently, but let's say we collected some data, some measurements of concentration, different times. So we have time and we have concentration of our product. And now we have two ways how we can solve this problem. First of them, you already considered last lecture. It's the so-called first principle model. Where you basically have some assumptions about how your reaction goes. So you have some sort of equation, and you can say the derivative of your product concentration over the time is equal the reaction rate as some sort of constant, and then you have concentration of your initial substances. In case we are talking about reaction that looks like something like that. In this case, we can also calculate the parameter key. For that, we can use Arrhenius equation and so on and so forth. And then we can try to fit some parameters in the Arrhenius equation and find to train the model. But in the real world, there might be some problems about this. For example, this simple model doesn't consider heat transfer, mass transfer, and also doesn't consider some specific parameters of the reactor, for example, or the system where the reactor is. And in this case, there might be some data that look like this, for example. So basically, there are some discrepancies in this area. For example, the flow that goes through the reactor is too fast, and that's why you cannot, you cannot cool it really fast, and that's why the reaction rate is higher here, and that's why you get like more outcome from the reaction. And this is exactly some problems you can have if you consider first principle models, because in this case you would need additional equations. For example, to solve mass transfer equations or problems, you would need, for example, Navier-Stokes equation. You might probably also for heat transfer and so on and so forth. The more equation you have, the more parameters you have as well. And all these parameters you need to fit as well. And that's why at some point you might consider that instead of building a very complex model based on first principles, you would like to use the data to just build the model only based on data. In this case, machine learning comes into play. So basically, it's ML or data-driven models. We can use. How do they work? So basically, machine learning models or problems, they have three major components. First of them is experience. So basically you use experience, or your measures, your data, that might be, for example, some sort of a table, and in this case we have time, and we have concentrations, and we have some data. Just simply the data we use to build our model on. Then we need a task. So basically we need some sort of transformation we would like to achieve. In this case, it's just some sort of a model we would like to have at the end of our modeling process. What it can be, besides, for example, in this case, it might be to find a concentration at a certain period of time. For that we do not have data, some sort of interpolation. It might be also some kind of extrapolation, although in very limited cases. But there are also other types of problems we can solve with machine learning. Besides regression, when we have continuous output of our model, we can also solve so-called classifications problem, where we would like to predict a class, so a value from a predefined list of values. We also can try to reduce the dimensions. For example, if you have 100 or 200 dimensions, you can imagine a lot of sensors installed in our plants, and we would like to say, instead of having 200 dimensions, we would like to have only 3 or 5 that are relevant, and thus reduce complexity of our problem. This is also possible with methods of machine learning. We can also try to identify some sort of anomalies. If we say we have 5, 6, 7 different measures or 100 different measures for the same experiment, but in slightly different conditions, and at some points we see that our reaction goes very slowly, and having other measurements, we can say it's more or less our normal distribution of our measurements, and at some points, if the discrepancies are too high, then we say it's some sort of anomaly. It's also a problem you can use machine learning to solve. Then the third component in this set would be to have performance. So that means not the performance, how fast we solve the problem, but how good we do it. So basically, having a model, it's good, but we also need to measure how good our model fit to the data. And in this case, there are, depending on the problem we would like to solve, for example, for regression task, for classification task, or clustering task, there are different measures we can use. And those performance measures, or you can name them also target function. So basically, what you would like to minimize or maximize solving this problem. It might be, for example, for regression tasks, it might be to reduce the difference between your model and your data points, so-called sum of square errors. For classification tasks and for clustering tasks, they also have other types of measurements that are types of performance measures that are more complicated than that. Anyway, the next time we will consider different tasks. We can also try to classify our machine learning problem types, and we also consider such tasks as regression and classification.